So in this lesson, we're going to apply our understanding of a numeric expression and their terms or parts and the operations so that you can recognize algebraic expressions and the terms and operations within them. You'll know you've got it when you scored an 85% or better on the assignment over the lesson. Okay, so we're going to review what we've already had this year in regards to expressions. And so this is a box that just covers numeric expressions. We've had these throughout the year. You've been doing numeric expressions for years through your elementary days. And numeric expressions do not contain an equal sign. So that's why we have this right here pointing out they do not have equal signs. So when you're asked to give a numeric expression, you don't put an equal sign in it. Numeric expressions include number terms. Remember, terms are an individual number or group of numbers, and they're separated by a plus or minus sign. Other operations like multiplication, division, and exponents can happen within a term. So we're looking at an example right here. This is an example of a numeric expression. It's got terms that are separated by these plus and minus signs that are highlighted here. And within the term, looking at our first one, within this term, you can see there's multiplication happening inside that term. This term, minus 6, is just a numeric term. And this term, plus 72 squared, has that exponent within that term. Notice when I identified the term, I circled the sign to the left of the term. And that sign is important to note because that tells you when we're working these out if you're going to add or subtract the 6, if you're going to add or subtract the 7 squared. So when we're identifying terms, you also need to include the sign to the left of each term when you identify it. Okay, so I circled each term over here following the directions in the box, and there are 3 of them. This is the first term, this is the second term, and this is the third term. Now, just to review again, what did we do with these numeric expressions throughout this year? Well, we did order of operations, so that should sound familiar. Remember, order of operations, our little memory abbreviation for the order of operations is GEMDAS. And I'm going to put some extra letters in that GEMDAS because we got to remember something special about the division multiplication step. I'm going to box that in. And the addition subtraction step. So I wrote it 2 ways. I wrote it following the GEMDAS, GEMDAS, but I also reversed those letters that I'm boxing in because we do not always multiply first and divide second. The order we go in is going to depend on the expression we're given. We are going to either multiply and divide first if a term has both, or we're going to divide and multiply first. We work left to right. And then when we're down to expressions that have addition and subtraction, that's left, we look at the terms and we go left to right as well. So looking at this first problem, I'm asked to simplify using the order of operations. So I'm looking at this first term right here, and I'm just going to run through this process right here. Are there grouping symbols in this term? No, it's just 2 times 5. There's no exponents. It's 2 times 5. There's multiplication only. So I don't even need to consider the division or division being first. It's strictly multiply. So I'm going to multiply and clean that term up. And we get 2 times 5 is 10. Now we go to our next term. There's nothing to clean up, so I'm funneling. So I just bring the minus 6 down. And then I look at this last term, and now I'm going to walk through steps because there is something to do here. It's 7 to the second power. There's no grouping symbol, so I'm going to check that off. There are exponents, so I'm going to go 7 to the second power, which is 7 times 7, which is plus 49. Okay, now that I've got that simplified, I am going to go down to my addition and subtraction because I do have no more operations within these terms. I'm ready to go left to right. So looking at this, the add then subtract is not the right order. It's subtract first because that's what's on the left. This right here goes first. So it's 4 plus 49. And then we are going to do our addition last. 4 plus 49 is 53. So we've organized ourselves by looking at identifying the terms, looking at each term, and applying our order of operations to those that have what we say operations within a term. We clean those up, and then we do our subtraction addition last. All right, so right here we've got new information. We just reviewed numeric expressions and how many terms there are, what the terms, identifying the terms, and then simplifying the expressions. So now we're looking at a new piece to add to your knowledge, and this is an algebraic expression. So an algebraic expression, just like a numeric expression, will not contain an equal sign in the expression. So if you're asked to enter an algebraic expression, you do not put an equal sign in your expression. Algebraic expressions include algebraic terms. So we had numeric terms, and now we got to learn what an algebraic term is. Algebraic terms include variables. There's the difference. Variables are typically letters, or groups of letters, or groups of variables and numbers, groups of letters and numbers, and they're separated just like a numeric expression by pluses and minuses. So the difference here is you're going to see letters in your expression. Numeric is only going to contain the numbers, numeric terms. Algebraic expressions are going to contain letters or variables in the terms. So here's an example right here of an algebraic expression. You can see it has the letter X and it has the Y in the expression. That's why it's called algebraic. Okay, so we're going to circle each term. They're also identified down here, but let's just circle each term. We've got 5x. Remember, circle the sign to the left of the next term, which is plus y, and finally minus 9. So there are three terms in this algebraic expression. 2 of the terms are called algebraic because they contain those variables or letters. And then the third term is not called an algebraic term. It's called a constant term. It's just within the algebraic expression. So we can have numbers without letters as well. So algebraic expressions will contain letters. Numeric expression, only numbers, no letters. So let's try identifying whether these 3 expressions at the bottom are algebraic or numeric. So I want you to pause the video. I want you to circle if you think this expression is numeric or algebraic. And then I want you to list the terms in this expression. Then turn the video back on to see if you have it correct. So looking at this, you should have selected numeric because they're all numbers in this expression. There are no variables or letters in this expression. And then the terms are 18. That's the first term. The second term is 9 over 3, or 9 divided by 3. And it is positive. I don't put the plus sign in front when it's positive. And the last term should be negative 5 times 4, or minus 5 times 4. This minus sign needs to be included because it's to the left of the 5, so it belongs to that term. So you need to include that minus sign. It's very important we identify that for our upcoming lessons. If you miss that, you're going to be missing problems. Okay, do the next one. 8x minus 22 plus 2x squared. Identify its numeric or algebraic, and then list the terms for that expression. Pause the video, turn it back on to see if you got it. So you should have selected algebraic because it has an x in it and it has an x squared in it. So it contains variable. The variable it contains is x. And then the terms are 8x. That's the first term. Then there's your minus sign that separates 8x from 22. And so it's minus 22. And then the next term is positive 2x squared or plus 2x squared. You just write 2x squared. You don't need the plus in front. It's assumed plus when you don't write it. Okay, so that is that one. Now do the third one. Identify if it's numeric or algebraic, and then list the three terms. When you're done, check to see if you got it right. So you should have selected algebraic, and your first term is 7.2. The next term follows that minus sign, minus 8b, and your final term is a plus 2 times the quantity 5.6k. So it's that 2 times 5.6k is your third term. Okay, so along with algebraic expressions and these terms, we need to get some vocabulary figured out so that we can talk and learn more about these algebraic expressions. So one key vocabulary word, we've used it already. You've probably heard it in your math before now, but it's called a variable. So a variable, we got to discover what that is. So we're going to go through an example. If you are a server at a restaurant, a waiter or waitress at a restaurant, and let's say you earn $10 each hour you're working, and then on top of that, you earn money on your tips. So trying to figure out how much money you're going to make after an hour of work is going to depend on how much you bring in your tips. You know for sure you're going to get paid $10. So this number is a given. It's a constant. You know that that's what your employer is paying you. $10 to be there for the hour, just in case you have some customers. So we'll call that the constant in this money you make. Okay, but on top of that, you're going to get your tips, but you're not exactly sure what you're going to make there because you don't know how many customers are going to come in and you don't know how much they're going to leave you for your tip. So that amount requires a variable if you're trying to figure out your amount that you're going to make in that 1 hour, because it's going to change. That tip amount changes from hour to hour. So to figure out how much you're going to make, we're going to need to use a symbol to represent your tips and to represent that amount that's going to change or vary. Okay, so in the algebra, these symbols, variables, are typically letters. We typically use letters to represent unknown amounts. So if I'm using a letter for this, I would probably use T for tips. And if I wanted to know how much I was going to make, I would say, hey, I'm going to take my tips and I'm going to add them to my $10. But rather than typing the word out, we're going to shorten it and just use a single letter to say, hey, let T equal the tips plus the $10 I make just for showing up to work for that hour. So the formula that we would use is T plus 10 because T is going to vary depending on how many customers come in. So let's think about it. Let's say that between 9 and 10 in the morning, you have some customers come in and in tips you made $7. So we would say, hey, I made $7. So altogether I made 7 plus 10, $17 in that hour. But then between 10 and 11, business picks up a little bit. People are coming in for brunch and you earn $15. So the next hour, that T is going to change out and we're going to put a 15 there. 15 plus 10 is 25. So in that hour, you made $25. And let's say 2 o'clock hits, the lunch rush is gone, and you make $2. One customer comes in, you made $2. So we put a 2 in here for T. 2 plus 10 is 12. So now you've made $12. Your amount is going to change because the tip amount does not stay constant. The $10 stays constant. That's why we call it a constant. But your variables are what are going to vary. And that's why it's called a variable. It's going to change depending on the time of day. Right, so now that we got that vocabulary term down, what a variable is and why we call it a variable, we're now going to look at why in algebra we don't use the X for multiplication anymore. So you need to get used to this. We do not use this symbol in the algebra world for multiplication. So In algebra, the letter X is often used as a letter, right? So we use it as a variable a lot. They like to use X in algebra. If X is used as multiplication, it could get very confused with the letter X that we're using to represent an unknown value. So when you see this, if this was the problem you were looking at, it's very confusing because you're not sure what that stands for. We read it, is it 2 times X, or is it 2 times X times X? What does this mean? Too many X's. So we do not use this symbol in the algebra world. So we're going to show you ways that you are allowed to enter your answers and write your answers so that you're using what we call proper notation. So here's one thing you can replace that multiplication symbol with. It's the dot. We've been using this. So 2 dot X means 2 times X. Or you could put parentheses around your X and just write 2 parenthesis X. And that also means you're going to multiply 2 to whatever this number is when we figure it out. And finally, we have 2X. No symbols at all, just 2 and the letter X translates to 2 times X. So all these three things, when you read it, you need to read it as 2 times X, where X is a number that we can plug in when we're ready to. So I would like you to read this expression, algebraic expression. It's algebraic because it's got variables in it. And I want you to read it, and then on this line, however you read it, I want you to write the words that you read right on this line. So read it out loud to yourself while the video is paused, and then write word form out for what you read. Then turn the video back on to see if you read it correctly. Okay, so you should have written this out as 3 times X minus 4 times Y plus 7. If you did not include the word times in both of these places, or synonyms for times, then you missed this. Okay, there's no symbol here because they dropped it out just to make things less confusing. They've simplified this as 3 and X, but that means times. There is an operation word that needs to be there, and the same here. Even though there's no symbol, you need to say a times or a synonym for times. And so if you miss that, you need to fix it. And then once you got it fixed, I want you to identify the 3 terms in that algebraic expression. Just to practice that again, turn it back on when you're done to see if you got the terms correct. Right, now that you've checked to see if you've got the terms, it should be 3x minus 4y and 7. If you left off the minus sign here, you need to put it in because it's the sign that's to the left. It belongs to that 4, so it needs to be in there. So include that. Now I'd like you to pause the video and list the variables in this algebraic expression. What are the variables? Turn it on to see if you got it correct. So there are 2 variables in this expression. There's the X and the Y. So X and Y are our variables. So far we've talked about an algebraic expression, and we're kind of breaking that expression down into the pieces that make it up. We have terms, and those terms are separated by the plus and minus signs. And then we talked about multiplication. Multiplication looks different in an algebraic expression than it does in a numeric expression. In a numeric expression, we're required to have a multiplication symbol between the 2 numbers that we're multiplying. In an algebraic expression, the terms that are being multiplied to the variables do not contain a multiplication symbol. So here is, right here we have 3y, 3 times y. So proper notation, when we have a number being multiplied to a variable, which we call an algebraic term because of that letter, the number comes before the variable. Okay, that's important notation. Lots of notation structure to the algebra. So we would not write this number as y3. That's backwards. We always want that number in front of the variable when we're multiplying with no symbol in between. Okay, these numbers that sit next to variables have a special name, and that name is called a coefficient. Fancy name for a number being multiplied to a letter. Coefficient. Spell it correctly. I got a line for each letter. It's a long one. And you need to learn this term. So you need to learn variable, you need to learn coefficient, you need to learn algebraic expression and algebraic terms. Algebraic terms are those terms in your expression with the variables. And they have a coefficient on them, a multiplier with them. Okay, so we're going to try to make sure we understand what a coefficient is when we look at an algebraic expression, and we're also going to make sure we know how to put that algebraic expression into proper notation. These are all things in this lesson you need to master. So the first example says, hey, these are not set up properly. We have a 3 with an x for multiplication and an h, 3 times h. So the coefficient is the number being multiplied to the variable, so it's 3. That's why we put it here. Identify the coefficient. Well, the coefficient is 3. Okay? And then once we got that identified, the next step we took was to make sure we put it with proper notation. Coefficient first, followed by the variable second, with no multiplication, the symbol in between. 3h, which when we read it, we should know it's 3 times h, even though the symbol is gone. Okay, the next one is 5 dot y. The dot is a multiplication symbol. Okay, so the coefficient is 5. That's the number being multiplied to the letter or the variable. So there's your 5. Okay, proper notation says, hey, the coefficient needs to be first. Well, it is. Came in front of the y over here, so that was right. But it says no multiplication symbol, so you ditch the dot and it's just 5y. Okay, this next one, d times 8. Okay, so identify the coefficient. It's the number being multiplied to that variable, which is 8. Okay, there is no multiplication symbol between the d and the 8. Good, it's not supposed to be. However, the coefficient needs to be before the variable, so it needs to be switched as 8d. Okay, try this one, cx4. That's a times sign, so translate that. Identify the coefficient here, rewrite it in the proper notation here, and then turn the video back on to see if you've got it. You should have had a 4 for the coefficient and 4 in front of C with no multiplication symbol. That is proper notation when you're entering in your homework this evening. Okay, you got to have it correct or it's going to go wrong on your assignment. So make sure you're getting it in the right order. We have m.12. That dot is a multiplication symbol. So fix that one up, identify the coefficient, and then write it in the proper form. Turn the video back on when you're done. The coefficient is 12. And we lose the dot between the 12 and the m, and the 12 comes in front of the m, and it reads 12 times m even though there's no symbol. Okay, this next one is a little different. Okay, it's just a variable. There's no coefficient that you can see. It is actually there, but it has been dropped. We say it's invisible. So the coefficient on this term is 1 times r. Logically, if you think about it, if r is 2 and we multiply it by 1, r stays 2. 1 times 2 is 2. If r is 8, 1 times 8 is 8. If r is a third, 1 times a third is a third. The 1 does not change the value of r because when you multiply by 1, it keeps the number the same. It comes right back. So there's no point to have the 1 when we're doing these expressions and we're writing them. It's just simpler to say r and ditch the 1 in front. So when there is no coefficient in front, there is a coefficient. It's just invisible. It's the number 1. Because we're multiplying it, it's called 1r. We drop it. Okay, so to write it in its proper form, we just write r. You don't need the 1 in front anymore. It's assumed to be there. So that's something you got to remember when we're doing our lessons here on out, because it'll play a part. Okay, so we covered what an algebraic expression is. We've covered what terms are in an algebraic expression. We've broken the terms down, so we're looked at just now the algebraic terms, the terms that have a coefficient and a variable that are being multiplied together. Now we're on to this last piece, and we're going to look at expressions, algebraic expressions that also have a numeric term in it. The numeric term is a number that's being added or subtracted that does not contain any variables on that term. So the two terms we have here are y and -8 or -8. And the coefficient is 1. Remember, if it's not there, we can stick it in so we can see it. The coefficient is 1 on our algebraic term. And this number right here that's being added or subtracted in this case, it's always going to come last in our expression. So it's coefficient, variable, and then constants will be at the end of the expression. So here's 1y minus 8. It's the last term on the expression. And we call that number a constant. If you remember the problem we did with the tips, the $10 you make for coming in for that hour is always going to be there. It stays there. It's constant. Okay, the constant never has a variable on it. It's just a numeric term that's either being added or subtracted at the end of our expression. So when we look at this column right here, we're saying, hey, this is an algebraic expression, but it's not in its proper format. So to put it in its proper format, we are going to switch so that the algebraic expression comes first and the constant comes second. So we just reverse that. So it's x minus 4. This one right here, 9 plus t, the numeric expression or constant, 9, needs to come at the end and the t needs to come in front. So we start with the variable terms first and we end with our constants. Okay, this one right here, we have -3 plus 3x. So again, it's not in the right order. My variable term should be in front of my constant term. So I'm going to take that plus 3x. And I'm going to put it in front, and I'm going to take that -3 and put it at the back. Note that that plus 3, I didn't stick a plus sign in front. We don't do that. It's assumed that it's a plus if we don't write that plus sign in when it's on the start of our expression. Okay, this expression right here, the constant term is at the end, so it's right where it needs to be. The problem with this one is that my c times 5 is not in the right order because the coefficient needs to come first and the time sign should not be there. It should be listed as 5 times c in that order without a multiplication symbol. All right, I want you to try this last one. It's not in the right order. Possibly it has some notation that shouldn't be there, so fix it up and see if you've got it right. So stop the video, rearrange it, and then turn it back on to see if you did it correctly. You should have had 12m. You should have ditched the dot and reversed the 2 so that the coefficient was in front of the variable for that multiplication algebraic term, and then it's a -7. That minus sign belongs to the 7, so we're going to push it to the back so that it's algebraic terms before constants. Okay, so I would like you to run through and identify for each of these expressions. The algebraic term is going to have a coefficient, so I want you to name the coefficients of each of the algebraic terms. Those are the ones with the letters. And then you're going to identify the constant, the number that's being added or subtracted. Pause the video, turn it back on to see how you did. Okay, check out how you did. The first coefficient is 1 and the constant is 9. The second one, our algebraic term is 3x, so the coefficient is 3 and the constant is -3. And our next one, the algebraic term is 5c, so the coefficient on that term is 5 because we're multiplying 5 to c. And our constant is 8. And finally, The algebraic term is 12 times m, so 12 is the coefficient. It's being multiplied to my variable, so it's in that algebraic term for this expression, and minus 7 is your constant. All right, you have dealt with algebraic expressions before. This isn't your first exposure to algebraic expressions. In elementary school, when you did perimeter and area and volume, those were formulas that had letters in them. So you've already done some with this, work with algebraic expressions in your math career. So let's try to make a connection between the formulas you used in your elementary days and the algebraic expressions that we just discussed right today to learn more about them. So when you have triangles and you're trying to find the perimeter of a triangle, well, there's 3 different types of triangles. Remember, perimeter is distance around a triangle. So if you have a scalene triangle, which is this one down here, that means the sides are not the same length. None of them are. So a scalene triangle is simply perimeter is taking the 3 lengths. They're different, so A plus B plus C. Taking the 3 lengths and adding them together. We know that these are can be different lengths because our letters are 3 different variables. So when we use a different variable, we're implying that they are not the same or may not be the same. The next formula for your triangles that you used in the past were for isosceles triangles. You may not remember what that is, so I'll remind you. It's when 2 of the sides are the same and 1 is different. So an isosceles triangle, the formula would be, initially, it would be, when you look at that isosceles triangle, the 2 sides are A plus A, and then the third side is B. It's different than the other 2, so we indicate it with a different variable to say those values are not the same. So then when we come down here, ultimately, instead of doing A plus A, we would just take one of the A's and double it because it's repeated addition. As a math student, we expect you to recognize that as a doubling. And you'd shorten your formula from A plus B to 2A plus B. And finally, you have your equilateral triangle. That's when all 3 sides are the same. So we use the formula A plus A plus A. You're going to add A to itself 3 times, which as a 6th grader, you were like, no, I'm not going to add it. I'm just going to triple one of the lengths. All I need is one side if it's an equilateral, and I triple it. So your formula was shortened to 3A. So it's super important that when you're dealing with these formulas, you're trying to use the shortest one possible when repeated addition surfaces in these formulas. So that's your perimeter of triangles. And those formulas, we would give you what numbers to put in for those letters. You would plug them in and do the math following order of operations to get the perimeters. The next one that you should be familiar with are rectangles. There are 2 popular formulas for rectangles. We're going to start off with how they develop. Again, this is review. You probably already know where these formulas come from. Well, it's a rectangle, so we only need a length and the opposite side is the same. So it's L plus W plus W. That is the formula for finding perimeter of a rectangle. That is how you start off learning about perimeter of figures, by adding up all the sides. But when you learn more about rectangles, you realize that you do not need to go L plus L because you just need one of them because they match. 2L plus, and then you realize I don't need 2 W's, I just need one of them, and I need to double it because they are the same. So you've shortened that formula from 4 numbers added together to multiply and then add, following order of ops. The other option that should sound familiar and review is that some students say, I'm not going to do L plus W plus W. I'm going to go L plus W. And then that's half of my rectangle. And I'm going to go L plus W again for the other half. So you just kind of go ring around the rosy around your figure and you get L plus W plus L plus L. But what you realize as you are doing that, hopefully, is that you did not need to do L plus W plus W. You could simply say, hey, I'm just going to go L plus W, just add half of it, half the figure, and then I'm going to double it. I'm going to multiply that sum by 2, and that's another way to get perimeter. So ultimately, these two formulas are the preferred formulas as you get into more advanced math classes like Math 6. Okay, finally, we've got perimeter of a square. Well, all you need for a square is one of the side lengths because they're all the same. You just take S plus S plus S plus S. They're all the same. There's 4 that are the same. So what are we doing? We're not doing S plus S plus S plus S. The shortcut is, since we're adding a number to itself 4 times, you just simply take the number and multiply it by 4. 4 times S. So that is the formula for that. And once they tell you what S is, you know just to multiply it by 4. Simple formulas for perimeter. And now we're going to check out the area formulas. So to start with the area of rectangles, you recall that you just take the length times the width, and that is the area of a rectangle. Simple formula, length times width. For a square, it is, some students will say, well, you do the length times the width because a square is a rectangle. Well, that is true, but it's specialized because it's S times itself. So it's S, I'm going to use the asterisks here for multiplication, S times S. And in 6th grade, you should have learned the shortcut for a number times itself. And the shortcut for multiplying a number, here I'm going to change a number times itself, is to do S to the 2nd power. So that is ultimately the formula we want 6th graders recognizing for a square. Because you learned exponents this year. When you see yourself multiplying a number to itself repeatedly, you shorten it with an exponent. Okay? And then the area formula that you should be familiar with for triangles is simply the base of the triangle times the height of the triangle. And you multiply those together. And we are going to divide that by 2. We're going to cut it in half. Base times height divided by 2. And so we would tell you what B and H are. You'd plug them in and you'd do the math to get your area. And the area of a trapezoid, you should have had this one as well. It's kind of a detailed formula because we have 2 bases that are highlighted there. We have the top base, B. We can call it B sub 1. Okay, so the trapezoid formula, I just put it in here. It's the base 1, the top segment, how long that is, plus the bottom of your trapezoid, how long that is. So you add those together, and then you multiply that by whatever the height of this trapezoid is. And then once you get that all worked out, B1 plus B2 times H, then you divide it in half. You divide it by 2. And that will give you the area of this trapezoid. You will want to make a note on your note sheet under this box that units are squared when you're finding area. So if, for example, write the examples down. When I'm tacking on the units, if this rectangle is 4 by 2, then it's 8 centimeters squared. And then if this square right here was 7 by 7, it would be 49 inches squared. So you have to make sure when you're putting units on area problems that you put an exponent of 2 on your unit so we know you measured area. Okay, so that's important to note on your paper. Okay, on this last slide, we have volume. That's another formula you have seen throughout the years. And we have volume of a rectangular prism and volume of a cube. So the volume of a rectangular prism we've studied is length times width times height. That's how you find the volume of a rectangular prism, a 3D shape made up of 6 rectangles. Okay, and then a cube is a specialized rectangular prism because all the edges are the same length. They're all the same. So this side is S, so is this side, so is this edge, so is this edge right here, so is this edge over here. All the edges are S. So if we're trying to find the volume, it would be a number times itself again. Length, width, and height are all the same. So we're applying this formula, but your numbers are going to match. And since you're multiplying repeatedly by S 3 times, the formula we expect you to use is S to the 3rd power. You should understand where that comes from. because it's a cube. It's special. The other thing to note on the bottom of this is that the units are cubed for volume, because that's what we're measuring. How many 1 by 1 by 1 cubes will fit in this particular figure. So if the answer was 27 cubes will fit, then it would be 27 centimeters to the third power. If the answer was 4.2 inches cubed, we would write 4.2, the unit is inches, and we would put the cube on it to indicate this is a measure of volume. If it had a square on it, we would know you measured area. If it didn't have a unit at all, we would know you measured perimeter. So that communicates what you're measuring. Without those, we don't know what you're measuring, area, volume, or perimeter. So you need to put those on to indicate what your unit would be so we know what you found. That concludes this lesson on algebraic expressions. Lots of vocabulary to learn and practice here that you need to recognize to be successful. So make sure you go back through the notes, pay attention to the vocabulary, pay attention to the directions when you're doing your homework for those words and those terms, because you have to know those terms to be successful in this particular unit. Good luck.